Alright, everybody got copied what they want on that? Humana. Okay, starting off here, some easy schmeezy simple stuff. I got the cube root of 27, then I've got the cube root of 216, then I've got the fourth root of 256, and then I've got the fifth root, oh no, we didn't make a list on that one, of 243. So I got 4 problems for us to talk about there. 1, 2, and 3, you ought to be able to get all those straight off the notes that you just made. So on that first one there, remember, let's do some definitions here while we got those up here. What is the number that I call the root? You know what that's called? There's actually a mathematical term. Like number 1, the cube root. I'm saying the root's 3. Anybody know the mathematical term for that? It's the index. Okay, so if you see that question on ACT or something, that number out in the root spot, this has an index of 3. Okay, what's the index of a sign that doesn't have anything written in the root?
Square.
Very good. It's understood square root, so its index will be 2. What's 27 called? It's a funny one. Start with an R. Radicand. This thing underneath is called the radicand. So this number 1 here has got an index of 3 and a radicand of 27, and that whole term is referred to as a radical. Okay? Like y'all are radical people. Alright, so the cube root of 27, what times itself 3 times equals 27? Look there at your chart on the perfect cubes, and it is 3. Cube root of 216, what times itself 3 times equals 216? 6. Fourth root of 256. Did we go that far? Mm-hmm. What is it? 4.
3.
Alright. Fifth root of 243. 3. Couple of ways we can get that. Okay. Go back to your fourth root. What was 3 to the 4th? 81. And then multiply that by 3 one more time. It'll get you 243. If you've forgotten how to do these in your calculator, square root button is over on the left. It's pretty easy. You got to push second. See that one over there on the left? Cube root. If you want a cube root, you'll hit math, go down to number 4, and there's your cube root. But if you want something bigger like this, we needed a fifth root or a fourth root on your normal home screen, the normal add, subtract, multiply, divide screen. I'm going to hit 5, and then I'm going to push math. And I'm going to go down to number 5, the one that has the variable in the index spot, and pick it. Then you'll type your number in there. Everybody see how to do that? That might be something come in handy. If you're taking ACT or anything. I think this Saturday's ACT is usually the last one colleges use on seniors. The December one, that's what I've heard anyway. Alright. Everybody okay there? Okay. This has got, okay, the page turned there, but not on mine. That's not good. I'm going to guess that means, let's still writing on mine. I guess that means I'm not connected anymore. Glad when I figure out how to work all this thing. Got it. Come on, you stupid thing. I wouldn't Making me angry. Get one more. Man, why's this stuff up? No. Well, what good you do? But I won't stay connected. I've done this one. Alright, when we got a fraction, this 4th root of 16 over 81 in your calculator, yes, it can handle that. What we remember is that means we're taking the 4th root of the numerator and the 4th root of the denominator. So you've got a list, both of those are on it. What's the 4th root of 16?
2.
2. What's 4th root of 81?
3.
That's it. Nothing to it, nothing to it. Okay, this one says the cube root of 0.064. Now you do this a couple of ways. You can use the cube root list that we made, even though 0.064 is not on there, there is a number on there that you can use, and then move the decimal, or you can just do it in your calculator. What is the cube root of 0.64? 0.064, excuse me. Close. Close.
0.4.
0.4. Because every time you multiply it by itself, that's 16. There's 2 numbers behind the decimal, so you would put 2 there. Then when you multiply that by 0.4, that's 64. 1, 2, 3 numbers behind the decimal. So we had to back it up. It's confusing to think of because I initially would want to say 4, but I only did actually 2 levels on that. Does that just totally blow your mind? Does not. Just moving decimals is tricky business every now and then. All right, let's look the difference that we have here. All right, number 1, square root of 36 is what?
6.
Negative square root of 36 is?
Negative 6.
Square root of negative 36 is?
6i.
6i, very good. It is 6i. For our purposes in this unit, we get to take the easy way out and say not real. It is 6i. We learned that in Algebra 2, and we're going to review it again in here, but we haven't yet, so for this unit, it's not real. But we remember, anytime we have a negative underneath an even root, square root, 4th root, 6th root, it is always imaginary, which is not real.
I like imaginary stuff.
Yeah. Okay. What about an odd index? What if I had the 5th root of 243 and the 5th root of negative 243? Okay, what's the fifth root of 243? We did it a second ago. What's the fifth root of negative 243? Negative 3. So you can have a negative when it's an odd. It's when it's even that it's no bueno. Because this means negative 3 5 times, which I can't say 5 and write a different number. I said 5 times and wrote 5. 5 times, which is a negative. I'm fixing to try to show you, Grace. You're still looking at me confused. Negative times a negative is a positive. Times that negative is a negative. Times that negative, positive. Times that negative, negative. So if the odd root is odd, you can have a negative. Alright, let's graph one or so of them.
Do you like the old one better?
I like the old remote writer better. I hadn't had time to figure out all that iPad stuff. Yeah. Alright, we got f of x is equal to the square root of x plus 2, the direction set of graph. You can, when you're doing this on a test, guys, y'all listen, when you're doing a test or an assignment, you can do that in your graphing calculator. It can handle that for you, not a big deal. I'm going to make an easy schmeezy input-output table real quick. I'm going to be careful about what numbers I plug in because I'm kind of not as smart as some people. And I can graph better if I'm graphing whole numbers. If I'm taking the square root of something and I want a whole number, it's got to end up being a perfect square. So like for example, usually I throw zeros around like crazy. I'm not going to put a 0 in this one. 0 plus 2 is 2, and what's the square root of 2? Well, it's not a perfect one, right? So I'd be dealing with the decimal. So let's think about, I can plug a 2 in. 2 plus 2 is 4. The square root of 4 is 2. What's the next perfect square after 2 squared? 3 squared is 9. How could I make this be a 9? What would x have to be?
7.
So I plug 7 in. 7 plus 2 is 9. Square root of 9 is 3. Now anything after that, it's fixing to be big numbers that I don't want to graph. Not only I'm picky, I don't want to graph fractions, decimals. I also don't want to graph big numbers. So let's go think about some negatives. What if I plugged a negative 1 in? What's negative 1 plus 2?
1.
And the square root of 1 is?
1.
There you go. I like negative 2.
I don't know.
What if I plugged a negative 2 in?
Maybe 0.
And the square root of 0 is?
0.
Now, what if I plug something smaller with negative 2 in? Say I plugged a negative 3.
Then you get funky.
Should be a big flashing red stop sign for you there because negative 3 plus 2 is negative 1. And we just said we're imaginary if we have a negative square root. So this is it. This is all I'm going to graph. Let's see. I got to count all the way to 7 on that one, so I better use every line. Right 2, up 2. Right 7, 2, 4, 6, 7, up 3. 1, 2, 3. Negative 1, 1. Negative 2, 0. So our graph, and if you did it on your calculator, you should see something that looks like that. Now think of something that we graph a lot in Algebra 3 and we did also in Algebra 2 that graph that we just made has some similarities with. Very good, Grace. That is a half of a parabola, isn't it? Can you envision the other half of it coming this way?
Yes.
Make a parabola. Wonder why a square root graph is half of a parabola. When a parabola is a quadratic, right? What's the highest power in a quadratic?
Square.
2. Very good. So you're looking at something that's squared. How do you undo a squared? Square root. So we just took something that was squared and we undid that. So it's like we took half of it off. Kind of is the way my brain functions on that. Okay. Other things that we had to talk about with this beautiful graph that you've made is domain and range. Domain's your x's. It's your left and right. Is this thing ever going to stop going to the right?
Yeah.
No. So it's going to approach infinity. What about the left? Where's it going to stop at the left?
Right there.
Negative 2. Does it touch negative 2?
Yes.
So that means bracket. Remember all that stuff? That was a long time ago.
Oh, yeah.
Alright, range. That's your Y. That's your vertical. That's your up and down. Is this thing ever going to stop going up?
No.
No. So we're looking at an infinity again. How low is it going to go? Is it going to go lower than this line? So what's the lowest? 0. Does it touch 0? Yep.
Yes, it does.
Point on it right there.
Oh.
So there's your range. But see, we had a 0. Look, there's a 0 in our Y.
Yes.
Now she remembers.
Oh, yeah.
Okay, whether you do that by hand or on your calculator, what if it had been a cube root? Could you graph it? Did you type in your calculator, make an input-output table by hand, either one? Do we need to do a cube root? They feel like they can do that? Y'all are usually pretty good at using those calculators. Alright, next, this is easy stuff. Y'all already know this. I got square root of 15 squared. I got the square root of negative 12 squared. I've got the square root of y squared. And I got the square root of negative y squared. Square root of 15 squared. What the heck? What's the squared and the square root do? We just talked about it.
They cancel out.
Cancel out. So all that's left is 15. What about here? This is a trick.
It's negative inside
It's going to be positive 12.
12?
Very good. Why did Custon and Zane get that? What do you get when you square a negative?
144. Or you can get
Positive.
144.
Right. Squaring a negative makes that a positive. So that's why good job on that, you too. Alright, even if it's a variable, square and square root still cancel out. What would this one be? Same as above.
5.
You got it, Sister Sue.
Yeah.
Alright, this one says the 6th root of y to the 18th. Two different ways we can do this, and we're going to talk about them both. Anybody think they got some good guesses on what the 6th root of y to the 18th is?
Isn't that y to the 6th?
No.
Third.
Zane's got it. It is y to the 3rd. Okay, so let's write equals y to the 3rd, and let's see if y'all can figure out how we got that.
Because the 18 power cancels out at 6, but you have to have the
Grace is on the right road with what she was saying. This one is actually, they're not all going to be this simple, but this one is because that goes into it evenly. So you can just look at that and say 18 divided by 6, and that works evenly. Other way to do it when it doesn't, because what if this had been y to the 19th? Okay, so we got to know another way to do it. Since this is the 6th root, what you want to do is write your stuff with 6s. Okay, what the heck does that mean? Well, y to the 6th, that makes 12. 6 and 6 is 12. That makes 18, right? Now, the 6th root and the 6th power cancel out, so that leaves you with a y. That happens 1, 2, 3 times. Okay, so if we had, let me give us another one here. Let's say I had the 5th root of x to the 16th. Okay, this isn't, Caitlin, you'll stop. This isn't the main point of today's stuff, but this is stuff that we'll see coming up real fast. 5th root, so I'm going to write them as 5s. x to the fifth, x to the fifth, that makes 5 and 5 is 10. There's 15. I gotta have 16. So I gotta have another x to the first, right? So now you got 5, 10, 15, 16. Okay, so it's starting off the same as the last one. The fifth root and the fifth power cancel out. So that means you got an x. And you have that 1, 2, 3 times. Right? So you mark all those out. You brought all those out to play in the wiffle ball game. Remember when we did that in Algebra 2? But on the inside still, you can't take the fifth root of an x. If the power is smaller than the root, you can't bring it out. So that would have to stay in the radical. So it would be x cubed times the fifth root of x. And that's not the main point of today's stuff, but that is stuff we did in Algebra 2 and that we'll be picking back up on here shortly.
Do we get on next Friday for Christmas? When do we get up?
And you get to come, well, semester tests are not next week, but the next. So we have all next week, tests start Friday of that week, and then follow Monday and Tuesday tests. Friday, Monday, and Tuesday tests. Okay. We need to draw a calendar.
No, I know what you would say.
I was thinking I don't really know how I'm going to draw it, so I'm glad you said no.
Maybe that's why it pops.
Alright, every now and then. Every now and then, this doesn't happen very often. Y'all listen, hoodlums. This doesn't happen very often when you're dealing with radicals. Most of the time it tells you to give the exact answer. This one, the exact answer, it would not change. Square root of 17, I would leave as the square root of 17. It's square root, so I'm looking at my perfect squares list, and 17's not on there. Nothing times itself equals 17. No whole number times itself. Every now and then you'll hear the directions or read the directions that will say approximate each radical. So that approximates telling you you're going to round, which tells you you get to type it in your calculator. Okay, so 17, let's round this to the nearest thousandth. That'll be 3 decimal places. If I take it to 3 decimal places, what would I get?
4.123.
Alright, now check this out. Square root of 17 is not equal to 4.123. If you work backwards and do 4.123 times 4.123 times 4.123, it's going to be super duper close to 17, but it's not going to be exactly 17. So I got to do very good. The squiggly equal sign means approximately. Nice job, GT. We're going to study some cave drawings from
He does.
our Zankinkers. Oh, man. All right, Michael.
I'm great.
All right. Going to be an exit question pop up momentarily.
Alright.
I guess I need to write it for you first. I was fixing to walk away and leave it. It'd help if you knew the question, wouldn't it?
I know.
I can't remember which one I did first period. I guess it doesn't matter. Let's do that one. Now there'll be a question of hearing momentarily.